Now the question on example number 3 relates to calculating the atomic weight of the isotope when binding energy per nucleon is given as 7.56 million electron volts. Now if we originally have the mass number and we have the actual mass, theoretical mass, we know how to find delta M first, mass defect, from delta M equivalent binding energy, from binding energy divided by mass number gives you binding energy per nucleon. This is what we know. Now in this question, we have to travel everything in the reverse process. How do we do? Let us see this. In the question which is given, it is the hint given in the question is uranium 92 238, and this is where we start our process. From this, what is the data we get? Number of protons is equals to 92. Number of neutrons will be equals to 146. So if you have protons and neutrons, can we find theoretical mass from this? Yes. How can we find theoretical mass? Yes. Delta M will be equivalent to, first we will find theoretical mass minus actual mass. This is the formula we have. But for this, first we need to find theoretical mass. So what can be the expected theoretical mass? So theoretical mass is equals to, we have 92 protons and each proton mass we know 1.0078 AMU, exactly taking 7825, and we have protons 140, sorry, neutrons 146, and each neutron having a mass 1.008665. This many number of neutrons in our structure. So now in the uranium isotope, if you calculate this, how much will be getting the mass? Expected mass can be around 239. I have calculated, so I'm just giving you the value 98499. So this is the value which I got. After multiplying the two data, we get this, adding that. Now delta M. Let us calculate delta M. Very easy. So what is the theoretical mass we got? 239.98499. Sorry, 98499 minus, let us see what we have in this particular one, the expected mass, this one, and what is the total mass which is given to us, we don't know. So that is the question. M is unknown. This is the question, actual mass they are asking you to find. So the actual atomic mass we don't know, so that should be taken as the unknown data. So moving forward to the data, this is taken as capital M. We don't know this. That is our question. And now what is the data we have is binding energy per nucleon, which is equals to binding energy by mass number. What is the mass number given? That is, binding energy is given 7.56 is the answer, which is equals to binding energy by total number 238. And now from this, what we can find, the binding energy can be found. What is binding energy? Is delta M 239.98499 minus M multiplied by 931.5 million electron volts. This is your binding energy, which will be equals to 7.56 into 238. So if you do this calculation, we will be getting from this molecular mass, which will be equals to 239.98499 minus of the total value comes to be 1.9315492. Approximately 2-3 digits also we can take, not an issue, just you can just get an approximate value. But as I have calculated, I'm giving you the total value, so don't worry about the data. You can do it approximately also, because it's a competitive question. 238.0534 AMU will be the answer what we got in the actual data. So let us check how much is the answer given, 238.0534. So this is the easy way we can calculate it. So what did we do? Again, I'll just revise it. First, we have to find delta M. For delta M, theoretical mass we have to know. Theoretical mass is number of protons into the mass number and the neutrons into the mass. So we got expected 239.9849. So after this, delta M is theoretical mass minus actual mass. The question is to find actual mass. So M, you keep it up. The data which is given, binding energy per nucleon, which is 7.56. So the formula says 7.56 is binding energy by total atomic mass number 238. So from this we found binding energy. Binding energy is mass number at theoretical mass minus actual mass into 931.5, which is equals to 7.56 into 238. From this we found out what is the M value, and that is our answer, 238.0534.